Hello, bonjour. My name is Baverne in France, Bouvenet. Okay, today this is a little bit of an instructional video here. We're going to talk about exciting some coils for the testing that's going to take place in Pasteur in Paris. Okay, alright, first we're in Wooddale. This is not my lab. This is Alan's lab. Okay. Here we are. This is the frame. Should be similar to what's going on in Pasteur. Okay. This is a cube. The vertical portion around the top is the top Z. The bottom, around the bottom is the bottom Z. And then the sides are X and Y's. So we're going to use this here amplifier. I'm servicing a unit at the moment here, but we're going to use the amplifier from it right now because I have it hooked up to the coils back here. So we're only concerned about using the Z channel, which is this one here, which we have marked, and it's also yellow, which is the top coil and the bottom coils. Right now I have it hooked up going to the function generator, and the function generator is a GWN, what is it, N-Stack. Alright, I have it at 0.2 hertz, which is the low end of what we're looking for. So that's all we're going to do today is the 0.2 hertz. So I'm driving it up at 8.4 dBm, but you can't really go by that because that's not totally accurate. So we need an oscilloscope, which is what we're using now. So right now, let me switch the input here. Alright, change inputs. And channel 1, which is the blue. Let me turn channel 2 off. Okay. Okay. 2 is off. Okay, this is channel 1, which is in blue. That's the input coming in from here to our X. Alright? And I'm driving it. It's a pretty high signal. That's what's going in back here. Alright, and the output is coming out of the amplifier into the coils. But I have a probe on the back of that, and this probe is on channel 2. So let me turn channel 2 on. Alright, and you can see they're both in phase right there, which is quite what we expect. And the scaling is different because we have a lot more power coming out than what's going in, because that's the whole idea of having an amplifier. We put in a small signal, large signal comes out, which drives the coils, which put out a huge field. Okay, and over here, in the middle here, we have a sensor. Okay, that's similar to the sensor which you're going to use to do the survey with. It's going to should measure this field here. Alright, over here, this is the data acquisition system, and I'm feeding it into my computer here. So let me bring up what's going on here. Alright, and this is the field here. Now right now I'm driving it with the function generator, and I'm able to push it all the way. I'm getting actually 500. It's a peak of 200 minus 300, somewhere in there, around 500 milligauss, which would be 50,000 nanotesla, which is way over what we need to do in Pasteur. So the whole point is we're having some difficulties with the function generator. So I found an app. Okay, so I have my S6 phone here, Samsung S6, and let me hook up this. Alright. Okay, this is a cable. Okay, and it's just from the phono output to a regular 3.5 millimeter to go right into this. Let me see, the earphone jack. The earphone jack of my phone S6 here. Alright. And I actually downloaded the app. If I can get to it. So I downloaded an app. It's called Function Generator here. Okay. And I'll bring that back up. Okay. Come on. Function Generator. There it is. So now I'm gonna disconnect. This one goes back to the function generator. So I'm gonna actually disconnect that. And I'm gonna use that as my source. Plug this in. Okay. Alright. And now alright, so now when you do this function generator, there's an out button to turn this on with. Okay, but when you turn it on, you can go to frequency. The default frequency is 400 hertz. So we're going to change that. We're going to enter 0.2 hertz. Okay, and then take the amplitude is at 50%. Let's enter 100 here. Oop. Let's try that again. Enter 100. Oh, come on. 100%. Okay, that's the maximum out at that frequency. Alright. Let's take the volume all the way in. Check the volume. Volume's all the way up. Yep, you can slide bar too. Alright, so we have the frequency. Alright, so now let's go check it up here. It's not quite as high as what the function generator is. So let's see what we do have. Alright, well, channel 1. Got to change the scaling on this from 1 to about, not quite. Change it to like 50. Okay. Not the best signal, but I think it's going to be decent enough. So let's change channel 2. Okay. Not a whole lot coming out. Alright. 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 So let's go over here and see what we're getting out here. Alright. 20 milligauss. No, hold on. Let's stop this. Okay. Figured out what the problem is. Alright. One thing you have to make sure with the phone is, with this app, that your phone volume is maximized. Mine wasn't, because whenever you plug something in, the volume does go back down to the default level. But you have to get, if you want the most out of this, you have to maximize it. So now you can see this thing is really pushing it hard here. So hard as it can, not as hard as a generator or anything like that. So let's bring the channels back, sensitivities back down. Okay, that ought to be good enough for that. Turn this one on a 10. Yeah, that'll work. So we're getting pretty good output here, it looks like. So let's go over here and see what we're getting here. Now, it's not as much as it was with the function generator, because now we're pushing it up on the upper limits. It's about half the power, about 3 dB. So we're at about 100 peak here, and then about 100 minus 100. So at about 200 milligauss peak to peak, which is about what, 20,000 nanoteslas, was way more than the 5,000 that we proposed. And so I think we can achieve what we want with the app, the function generator app. Not totally sure how the pass-through system is going to react, because every coil is going to react different, especially that one has a shield that it's next to. I don't know, but I'm confident that we can make the 5,000 nanoteslas with the phone as a source. I do recommend having an oscilloscope so that you can see what you measure what you're doing. But not totally necessary, though. You could get around without it, but I do recommend it. Of course, a function generator would be best, but this can be done with just the phone. Okay.